Okay, so idea is to find the curve length through calculus. So that is the concept that in which we will proceed on. Now idea is to find the curve length based upon the calculus. So curve length means I have a curve and how I can find length of the curve. So curve can be circular, curve can be anything. So curve can be means it is a line. So it can be circular or it can be a straight line or like this, whatever. What is the length of the curve? That is the concept. We have seen differentiation. Differentiation where we can calculate the extreme point. We have seen integration where we have collection rate of collection, the net collection we can calculate through integration. Differentiation, integration. Then we saw vector and then parameterization in vector. Then we can do calculus on vector also where we have ready-made direction possibility through vector, and then we have x component, y component, z component separately along the independent axes I, j and k. So now we have kind of everything. We have parameterized vector, we have differentiation, we have integration. So differentiation, integration in algebraic function, differentiation, integration in vector form. So everything we have. Now we have. Now can we use vector is important in a sense that if I have a vector, vector has a direction and vector has a strength. So what is the strength of vector? We can quickly find out, and what is the direction of vector, that we can find out. So vector has parameterized vector, a vector with algebra pushed inside it. So hybrid model of vector and algebra is parameterized vector. If there is a vector r, then r, and on top of it I can place an arrow, then it becomes a vector. Inside the braces, if I put an independent variable x, then this vector is called parameterized vector because all the components x, y, z. So x, y, z, rather than independent component as x, I can say t. If the independent component t, then x, y, and z component of the vector can be algebraic equation, algebraic function in terms of t. So algebra, the parameterized vector, normal vector. So parameterized vector become, since it is a all three components separately are function of an independent variable, it becomes a participant in making calculus over it. We per component wise, x component, y component, z component, per component wise we can do integration and differentiation. Means vector, you are marvelous, you are amazing. There is nothing that is beyond the parametric vector. What is the biggest problem here is, if you have algebraic equation, then how to bring it to single independent variable parametric vector, that is always a concern. So that is the thing that we see in the vector. Okay, so very nice it is, but how we can calculate from the parametric, from the algebraic equation to parametric vector? Then we have to find vector field from the algebraic equation. Now vector field itself is a vector which produces the vectors. Now vector field is a velocity field. If I differentiate the algebraic equation and get the vector field, now the component wise, if I integrate it back, then through some way I can get the parametric vector if I am lucky, in the sense that it is simple one. If it is very complex one, then probably we would not do. So there is no direct manipulation of parametric vector and algebraic. Similar thing we will see here also. Now idea is that if I have a algebraic equation, if I have a parametric vector, anything. Both are same. If I have a algebraic equation, if I have a parametric vector, then can I calculate the curve? If algebraic equation, it represents a curve, algebraic equation, if it represents a curve, or parametric vector, it represents a curve. Curve is a line, may not be a straight line. Then can I find the length of the curve? That is the idea. Now, if we see general tendency of integration, then if I have rate of change, means if like I say that this is example generally I give, a person is walking and he is collecting 5 kilometer per hour. Then his rate of or velocity of walking is 5 kilometer per hour. If I do integration, means if I draw a graph of 5 kilometer per hour, then if I calculate the area, then I get the net kilometer he has walked. So 5 kilometer per hour into 3 hours, then it x-axis is r and y-axis is kilometer per hour. Then it will form a rectangle which has height of 5 kilometer 5 and width as 3. Then area of rectangle is the net collection we make. So if I have collection per hour, if I want the net collection, then I have to integrate it, means calculate the area. Here the discrepancy happens because there are theorems of the calculus where they go with the infinitesimal small. I am reiterating that books we concentrate on this philosophy, that I can divide into strips and each strip is a small dx width, and then since it is a dx width, then I can approximate the area height into width of one strip, then I keep adding, then it becomes the net integration. False. So whatever the calculus that is being going on are false. Means this is straightforward. If people would proceed on those kind of things, certainly they will meet a wall. Wall in the sense that now calculus is not in hand of blind people, means people who are carrying the mathematics in the world. So they are people making people blind. Means things are wrong. Things are in different direction. I won't say that if you make infinitesimal small strips and each strip, if you calculate the calculus, then if you add, then you get the integration. This is true, but this is only approximation. Approximation is a kind of that someone is want job because he has to feed himself. There is no alternative. I work during daytime so that in night I can have food. If that kind of compulsion is there, where you are not able to calculate the integration calculus, then that is the last way where you can divide into strip and then multiply by the vertical and horizontal, and you get the area of one strip and calculate the area. I know what is this term called, who is the person who has given this technology, but this would not work. This should not be a fashion. This would be considered as kind of last sword. Like if I want to drink milk, then I go and buy plastic milk. So plastic milk is not the permanent solution, right? It is something that is the compulsion. Means you don't have any other solution, then only you go there. Otherwise, why you would go with the, you know that it is going to be poisonous. But still, poisonous is also okay, but without with dying with hunger or something like that. That is the last sort in calculus where we, so people say that if you something like then multiplied by dx is a small strip, and then that is the width and fx is the height, so fx into dx becomes the area, then dx you keep so many items. This is called integral. This is called numeric integral. Numeric integral is last sort where you don't have any solution. Otherwise, algebraic equation is the most natural algebra and it has no approximation. It is exactly perfect. So if I say fx dx, then people generally think fx is a differentiation of something. That is true. Like if I say fx is collection per hour, means person is walking, is collecting kilometer. So he is collecting 5 kilometer per hour. So collection, If fx is collection per hour, then if I multiply collection per hour, if hour is x-axis, then dc by dx is fx. D collection by dx is fx, where x is hour. Now df by dx, if I integrate with dx would cut down, then I will get fx back. I mean, get I collection back. You get the collection back, but dx is not written that you cut down and you get the collection back. Dx is just a notation that you have to calculate the area. If you don't follow this, then certainly artificial intelligence and machine learning, where you have so complex vector mathematics, there your fundamental will not work. So that's why it is serious. Now, calculus is not going to become a cakewalk, a child's doodle. It will come in full-fledged and full-fledged blow to the people who think taking the sideways. Like I go to the shop and pay money, I get the plastic mill. Or you can say that is proposed by some French people or something like that. Oh, I don't know. Pasteur, Louis Pasteur. So I follow Louis Pasteur. I go to the this is not the Indian way. Indian way of living life and thinking is different. And it will bounce because requirement is very high. That's why we are here. It's not our passion to come and talk about calculus what has already happened. Full-fledged, 100% we are talking what is the future, not what has happened. What has happened is very minute in the calculus. The way that people have found electromagnetic wave, 3 lakh kilometer, 3 into 10 to the power 8 or something like that. Means 300,000 kilometer or 0.3 million kilometer per hour is the speed of electromagnetic wave. And Einstein says that this is the fastest energy, that is electromagnetic wave, is in the universe. That is the electromagnetic wave. Sunlight and everything travels through 3 to the power 10, 3 into 10 to the power whatever it is, that makes the speed of the light completely false. This is something like you are not even born. If electromagnetic wave itself, it has steps. This is the beginning step, that is 300,000 kilometer per hour. Okay, then their concept I am seeing that scientists, they are showing that from the star, if I see a star, then probably it would not exist the time I see, because light comes and it travels at 3 into some 10 to the power something kilometer per hour. The time it reaches to our eye, it is years or thousands of years or light year. So stars would completely false. Okay, so these fundamentals would not work now. So when I see a star in the sky, star is there at that moment only. So the whatever the science now, right now have algebra to electromagnetic, whatever it is, this is mere a kid. This is not even a born. Science that will proceed, that you will see. So Indian way to proceed in the science that people would see. Like if I communicate someone, if he's sitting on Mars, then it takes 20 minutes, I think around, or half an hour to go the signal and come back. How big is Mars if you compare the solar system, and how big is the galaxy, that is the Milky Way galaxy, Akashganga, and then how big is the collection of galaxy and how big is the universe. Then God has made that you just with the Mars. Mars is something like person is touching me and sitting here. If I compare the size of the Earth, that big only. So if Mars electromagnetic radiation goes and come back and it takes half an hour, then this is the Einstein theory. So what will happen if I need to communicate something that is outside the solar system, that is still, it is very near. If I see the Milky Way, then this is how it is being it was constructed by the God. God is nowhere. So the calculus, what we are talking, that is the future, not what is talked in the book, infinitesimal small delta x, and then we multiply and here and there. Calculus is not the science of approximation. Calculus is the science of algebraic equation. Now it is moving towards vectorization, parameterization, and there we will see how we can take it forward. Because at the end, you have to give the result, and result should match whatever you see the maximum in the universe. So at the end, you have to come somewhere that God's creativity is there. If I need to just watch the solar system itself, then probably it will take hours and hours and hours to communicate to any device that I keep on Pluto. Come back, go, and that is like a frog in a well. He thinks this is the world. This is not the world. Okay, there are bigger thing to universe also. So, so life is going to be difficult day by day. So retiring or just shouting is not the solution that you can mute someone. Anyway, so now if I see the integration sign, so integration is a funny way to calculate the addition. And if I say fx dx, fx dx is nothing but fx. I'm trying to calculate the area of the fx, and dx and integral I put this is just a symbol to show that I'm calculating the integration or addition through area. There is nothing more to it. Dx is not area, the fx is a kind of dc by dx I cut down and I get the c back. That is not the dx. Dx is just a symbol there. You can remove the dx completely, not required. So fx and just place a integration sign. That is also enough because it gives a hint. If I place an integration sign inside that, if I write fx, it gives a hint that I have to calculate the area of the fx. Dx I say rather than dx, I can denote it by I and arrow. Means I have to calculate the area where independent variable is along I unit vector. So that is the concept. So like you can see the directional derivative and those things are coming. They are generic and they are along any unit vector. Now we can proceed with the another research. So directional derivative we have done. What about directional integration? These are things that would come now. So if I have f and I arrow, then I know that f area I have to collect with respect to the I axis. Directional integration along I axis. What about the directional integration along any vector u? Generally we do along the orthogonal, that is I vector or j vector. But what about doing it with the u? What you will put there, du or whatever. So it is in u direction. Here it is an I direction. I can omit this, and if I say integration of fx, people would understand if x is the independent component inside the braces, then it proves that I want to calculate the area of fx with respect to the independent variable that is on x-axis. Okay, so so dx is mere a hint that independent variable is along the x-axis. It is not that dx is infinite, it's small, and if I take and then multiply it by fx and this strip, that strip. Anyway, if you are happy with that concept, then and you proceed, then all the best. I am even happy to see that. But that actual calculus that will anyway it will come like directional integration and those kind of things, then you can see. Anyway, now the idea is to calculate the curve length through the parametric vector, and it is important in a way that we have differentiation, integration, magnitude, everything comes into the picture as far as curve equation is concerned, curve length is concerned. Like if I have a circle, what is the parameter of this curve? Okay, the if the circle is a if the circle is a centric on origin, if this is the origin, and this is the perimeter, if this is the origin and this is the perimeter of the circle, then what is the length of the perimeter if this is the origin? That is the concept. Now if this is the origin and this is Then if this is origin, then this is x-axis, this is the origin, this is y-axis, y-axis, x-axis. If that is the case, then what is the equation of the circle parameter? That is x square plus y square equal to r square. This is what we saw. If I take r radius as 1, that comes to x square plus y square equal to 1. That is y equal to 1 minus x square square root. Okay, that is the one way. Now if I do so, then each point on the circle, if this is the center, if this is the center and this is the perimeter of the circle, then each point on the circle perimeter from center, if I draw a line, then this is called position vector of any point x comma y. If that is true, then the position vector of x comma y is xi plus yj. Okay. Now, if I keep changing the xy point, then the p position vector, the p vector keep changing. So position vector would start from here and it is keep changing. Okay, how a position vector changes, from one point to another point. If I have x1 y1 and if I have x2 y2, then how much I see? So x1 y1 is independent component, so y1 is calculated over x1 1. So if I have a point on x-axis, that is x1, if I have x1 and if I have another point on x-axis, that is x2, if this is x-axis, then there is one point x1, so this is the point on x1. There is another point x2, this is the point on x2. Now if I have moved delta x, here delta x has come, if I have moved delta x or x2 minus x1, then how much change I see in the position vector? Because position vector represent the parameter. So dp by dx, dp by dx. This is what, if I change along x-axis a unit, then how much unit p is changing, dp by dx. If it is xi plus yj, then y is nothing but 1 minus x square square. Then dp by dx is x component of the vector, that is I now, dx by dx I now, plus 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 then 1 minus, then square root of 1 minus x square j. Okay, then d by dx of square root of 1 minus x square, then it will come as minus x by square root of 1 minus x square. Now dp by dx is I minus x by square root of 1 minus x square j. So this is the now we have this, we can call it velocity vector. If I have a position vector, then if I do derivation, differentiation, then it turns up to velocity vector. Now velocity vector is I minus x by square root of 1 minus x square j. If I do the integration of the velocity vector, because velocity vector is dp by dx, if I do it, this is rate of change as per the dx. If I calculate the velocity vector, if I have calculated the velocity vector, if I try to get back the position vector, I have to do integration. But I don't want position vector, I want the length. Then what is the length of the velocity vector? Then if I integrate, I'll get the length of the curve position vector. So length is the magnitude of the velocity vector. So that is x square plus y square square. Now it will come as 1 plus x square by 1 minus x square whole square root. Then it will come as 1 by 1 minus x square square. Now if I do integration of this velocity magnitude, then I'll get the magnitude of the position, that is the length. So if I do integration now, so okay, so dp by dx, whatever I get, if I calculate the magnitude and then on that magnitude, if I do the integration, on that magnitude, if I do the integration, then I'll get the length of the curve. Okay, straightforward. Now, if I do the integration of 1 by a square root of 1 minus x square dx, and then I have to integrate the curve from the left limit to right limit for which I want the length. So 1 by 1 minus x square root dx, the integration is sine inverse x. We saw how it is. If I set x equal to cos a, I mean x equal to cos theta, x square plus y square equal to 1, then y automatically become sine theta. X is cos theta, then y becomes sine theta. Cos theta plus sine theta. So cos square theta plus sine square theta equal to 1. If x square plus y square equal to r square, then we can consider as r cos theta. So r square cos square theta plus r square sine square theta equal to r square. Straightforward. Now anyway, I have taken radius as 1 for simplicity. So if x is cos theta, then dx is, if x is cos theta, then dx is minus sine theta. Dx is minus sine theta. If that is true, then 1 by 1 minus x square root will become sine theta. Sine theta. Okay, that we have to kind of, it would cut down. Okay, 1 minus cos square root would become kind of sine theta. 1 minus cos square theta sine square theta. Then it would go. Now minus sine theta cut down. So minus d theta. Now if I do the integration, then I get theta minus theta. What? Minus theta, if sine theta equal to x, then theta is equal to sine inverse of x. Then, okay, so it is minus theta. So sine inverse x equal to cos theta. So theta is equal to cos inverse of x. X equal to cos inverse. If I have taken cos theta, then theta is equal to cos inverse of x. Okay. Okay, so very nice. If I have cos inverse of x, and now I am trying to calculate minus 1 to 1. So if I place cos 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 inverse of, okay, now it is cos inverse x, that is the integration. So theta, it came as integration cos inverse x. Now if I use the limit, then it is minus 1 to 1. Okay, now x is 1. X is 1 when it is only possible when it is pi. X is 1 means it is pi, and 0, then 1 and minus 1. So minus 1 is only possible when it is 2 pi. When it is cos 0 is 1, whereas cos pi is, if cos 0 is 1, then pi is minus 1. So now cos inverse x, limit is minus 1 to 1. So 1 is 0 and minus 1 is pi. So minus pi, and minus is outside. So the length of the parameter from minus 1, if this is the origin, if this is minus 1 to 1, here it is pi. The full length is 2 pi. Now someone can move ahead and he can now substitute x equal to r cos theta and y equal to r sin theta. Then he can proceed. Then probably he will get 2 pi r. So now we have got the parametric, we have got the length of the parameter through parametric vector, through the kind of Cartesian coordinate. Right now we have Cartesian coordinate only. If I see the polar coordinate, so polar coordinate, if this is the origin, then any point, if I see the position vector, then polar coordinate, if there is a theta angle, then the position vector is r cos theta I plus r sin theta j. R cos theta I plus r sin theta j. That is the position vector. Now if I get the velocity vector, then it would come as minus r sine theta I plus r cos theta j. If I calculate the amplitude of this, then it would result in r. Now r, if I do integration of the r, then it will come as r theta. Now theta, I have to integrate minus pi to pi. Then it would result in 2 pi r. Since it is in polar coordinate, then minus pi to pi, it takes over the complete circle. Whereas there minus x square plus y square equal to r square minus 1 to 1, then it is half 1 in the Cartesian we had taken. So this is the kind of this is the way that we calculate the curve length. Now we can do more in it. This is not the like ellipse. So ellipse is x square by a square plus y square by b square equal to 1. Then y equal to 1 minus x square by a square whole multiplied by b square square root. Then it would come as b by a, and inside the square root a square minus x square. So a square minus x square. B by a into square root a square minus x square, that is the y. Now we can find the dp by dx, position vector differentiation dp by dx. Then what it would bring, dp by dx. If it is dp by dx, then xi would result in I, whereas now we have b by a and then square root a square minus x square j. If I do the differentiation, then it would kind of result in minus b by a x by square root a square minus x square. Now, if I go with the magnitude of this vector, if I go with the magnitude of this vector, I minus b by a x by a square root of a square minus x square, it would result in 1 square, means 1 plus b square by a square x square, b square by a square into x square divided by a square minus x square whole root. Now dx, the dx, if I integrate with the dx, then dx I can modify it to, now x I have taken as a cos theta, then certainly the y will be b sine theta. So that x square by a square cos square theta plus sine square theta would equal to 1. Now, if I say dx, then it would become minus a sine theta. So, minus a sine theta d theta. Integration in the integration side. Now, we have now 1 square minus b square by a square into x square, 1 square minus b square by a square into x square divided by a square minus x square whole root. Both this is very complex. Okay, so numerator is at the place where we are doing the differentiation dx, there it is now minus a sine theta d theta, and I have to do integration of 1 square minus b by b square by a square x square by a square minus x square full square. So this is not it. So someone can try this. Okay, that is one way. Another way, that's why I say whatever we are talking, it's our representation. It's no, you will not find in any of the book. And why we are here? Because calculus is going to become real calculus, where you will have very complex machine learning, artificial intelligence calculation through vectorized calculus. That is going to be future. So now we are trying so many ways that someone can proceed in any way, whatever he thinks perfect, and sometimes the perfection comes when you create the hybrid model. So when you create hybrid model of all the approach, like parametric vector, we have hybrid model of vector and algebra both. Now if we are trying to calculate the line of a curve, then vector, algebra, then magnitude of the vector, direction of the vector, differentiation, integration, everything if we are mixing, then only we are able to calculate the curve length. So if our approach are many, then hybrid model what someone would create from many would be certainly very powerful. So that is the concept here. Now consider another approach. Now consider that I am calculating area of ellipse. So it is x square by a square plus y square by b square equal to 1. Now x equal to a cos theta. If x equal to a cos theta, then y equal to b sin theta, then only it will be 1. Now consider that x equal to cos theta, then what is dx? What is dx? If x is cos theta, then dx is d of a cos theta. Dx, xi, now I replace with a cos theta. What is dy? Dy is b, d of b sin theta. D of b sin theta. Leave here. Now we have x square by a square plus y square by b square equal to 1. Anyway, the position vector now, if it is circle, now if it is ellipse, then position vector at any point is xi plus yj. If that is true, xi plus yj. Now now if I want the velocity vector here or vector field, then I have to calculate d of dx by dx I plus d of dy by dx, because we are calculating variation along the x-axis. There is only one independent component, that is x-axis, x. So how if I make a unit change along x-axis, then how p would vary? That is the scenario, dp by dx. So if I make unit change along x-axis, then how p would vary? If I know dp by dx and then we calculate the magnitude, if I integrate it back, then instead of getting the position vector back, I get the line. That is the idea, reverse way. Now what is dp by dx? If p vector is xi plus yj, then what is dp by dx? That is d of dx by dxi plus d of dy by dx. Now d of x, okay, so d of derivative of x, so derivative of x means x is a cos theta. Derivative of x is where x is cos theta by d of a cos theta. So d of a cos theta with respect to a cos theta only, it would result in 1. So 1i plus d of b sin theta, where we have to differentiate with a cos theta. Okay, if I take out the constant also, so b by a, then derivative of sin theta with respect to cos theta, not theta, d by d of sin theta with respect to d of cos theta. This is very difficult. So ellipse we hang somewhere, but if someone can proceed here, then probably life would be very easy. Now whatever you get, just you have to do x component square, that is 1 square plus this square root, and then dx dx, now it would turn, it is a cos theta, then dx would turn to minus a sin theta d theta. So minus a sin theta d theta integration, and then here the integration, whatever the integral part is, where which I have to do the integration, is a square root of 1 square plus d of sin theta with respect to a d of cos theta whole square root, and then minus a sin theta d theta. If someone is able to crack this, then actually you crack the parameter of ellipse, which has not been cracked by anyone else till now. All are providing approximation only. You know that I hate approximation. So you have to come to some way now that you find d of d sine theta by d of cos theta and calculate the parameter of ellipse the way it should be. Now, what is the ellipse representation in polar coordinate? That you can check, and then probably you can calculate the parameter through the polar coordinate. Okay, so this is two dimension. What about three dimension? Three dimension in the sense, okay, I'll take one more example in two dimension. Then three dimension I had thought that I will start today. Whatever I can do, I'll try now. Suppose there is a line that intercepts x-axis at 3 and it intercepts y-axis at 3. So x plus y equal to 3. When x is 0, then y is 3. When y is 0, then x is 3. If that is true, then x plus y equal to 3. Now, if this is a scenario x plus y equal to 3, then what is the length of the line between x-axis and y-axis? X plus y equal to 3. That intercept, what is the length of the line? If that is true, then what is the position vector? That is xi plus yj. Now, xi plus 3 minus xj. If I calculate dp by dx, it will result in I minus j. Now, if I calculate the displacement power of this dp by dx, then it would result in 1 square plus 1 square square root. That would come as the square root of 2. Now, this power, if I go back and in integration and calculate back the length, then it will be a square root of 2 dx. That would result in a square root of 2 x. Now, x I want 0 to 3. Then 0 to 3, that will come as 3 square root of 2. So now we know that the length of this line that intercept x-axis at 3 and intercept y-axis at 3, the length of this line is 3 square root of 2. Through Pythagoras also it is true. If this is 3, this is 3, then 3 square plus 3 square root, that is 3 square root of 2. So we can prove the Pythagoras theorem through this line curve. Can we see this? Someone can try now filing a disclosure that we can prove Pythagoras theorem through parameterized vector integration and differentiation also. So a square plus b square square. Anyway, now we will move to 3D. If I have 3D, then I have a plane. I have a plane. So plane, this is x-axis, this is y-axis, and this is fxy or z. X-axis, y-axis, and z. Okay, so this is fxy. Now in this plane, I have a sphere. In this plane, I have a sphere. Sphere is centered at the origin. Sphere means big kind of circular item. Okay, so I have a sphere and a sphere is centered. Like I had a circle centered at origin. I have a sphere centered at the origin. I want to calculate the surface area of the sphere. Can we calculate now the surface area of the sphere? How we can calculate? Now, if it is a sphere, then to calculate the surface area of a sphere, then what we need? How we calculated the length of a vector? If I want length of a curve, similar way I'll get the surface area of a curvature. What is the position vector? So, position vector, if I see what is the equation of the surface, what is the position vector? Now, position vector is 3D. It has x component, it has y component, and it has fxy component or z component. Xi plus yj plus zk. This is the position vector. Then dp by dx is I plus 0 because y is dx, we cannot differentiate, plus dz by dx. Z is fxy, function over x comma y. So dz by dx or dfx by dx. So the dp by dx, okay, so dp by dx, first independent component, dp by dx is I plus dfxy by dx fx k. Now this is dp by dx. How much I can see variation in p, 1 unit variation along x-axis. How much I can see variation p, 1 unit variation along y-axis. Okay, so 1 unit variation along y-axis. So that is the concept. Two independent variable. The two variation that is seen in P, one is because of variation along x-axis and one is because variation along y-axis. dp by dy. So dp by dy is j plus dfxy by dy k. Okay, if that is true, then what is the area? Now we have two vectors, two velocity vectors. One is dp by dx, one is dp by dx, one is dp by dy, dp by dx, dp by dy. If I have a sphere, imagine a sphere, then if I take a small strip there, that is the area strip. So sphere, consider sphere is a hollow sphere, balloon, football. So if it is a hollow sphere, then on the surface of the football, if I make a cut of an area and that area has delta x, that area has, if I cut 2 points, if I cut 2 points there, then 2 points will have variation in along x-axis, 2 points will have variation along y-axis. They are not along x-axis, they are not along y-axis. They are somewhere 2 points. So one has x1, y1, other has x2, y2. Then what is the area of that strip? Okay, then that we don't know. If I know that area, then I can I can generalize it for the full circle. This is the typical fundamental of approximation. But as we say, approximation is well enough when it is still the fundamental only, not in the practical. So anyway, now we know that if I calculate now x2 minus x1, if I say, then for x2 minus x1 I have z2 minus z1 dz by dx, okay, or x2 minus x1 or x2 y2 minus x1 y1, then it is dp with respect to change in these 2 points on it. Now x-axis has x2 y2, xy plane has x2 and y2 on the plane. If xy plane is there, on the xy plane I have 2 points x2 y2 x1 y1. For those 2 points, if it hits the surface, then we have x2 y2 z2 x1 y1 z1. Now if position vector is p1 and p2, then what is dp, what is differentiation in p2 and p1? p2 minus p1, that is delta p, p2 minus p1 divided by x2 minus x1, that is dp by dz, that is I plus dfx by dx k. What is p2 minus p1 by y2 minus y1? dp by dy, that is k, that is j plus dfxy by dy k. Okay, and z is the vertical component. So with these two independent component, we had dp by dx, dp by dy. If I know dp by dx, the variation in p with respect to x, and if I integrate along the x-axis, then I get the one component. If I integrate along y-axis, I get the another component of the surface. Since it is along x-axis and since it is along y-axis, if I multiply these two, I get the area. Okay, so for any surface, either it is tilted or whatever, If I have two position vector, if I know dp by dx means with variation along x-axis how much p is changing, with variation along y-axis how much p is changing. If I integrate one, then I get this length. If I integrate other, I get this length. If I multiply these two lengths, then for that area, that region, I calculate the area. If I consider like this, then full sphere dp by dx, I multiply with the dp by dy, I get full area. dp by dx, and then you integrate, I mean dp by dx and integrate, and dp by dy integrate, if you multiply, you get the full area. The way in the single variable we got, if I have a circle and yeah, if I have a p vector, dp by dx is talk about the variation in p along the x-axis unit vector variation. If I do the integration, if I calculate the magnitude and if I do the integration, then full x-axis along what how much p is varying as far as the kind of the integration is concerned. If I calculate, then I calculate the length because p is varying like this, and if I integrate along x-axis, then we are calculating the net magnitude. Same way, if I have area here, p is rotating on the p is a single dimension. P is moving along the curve. Now p is two dimensional. dp by dx, dp by dy. One p I get if I integrate dp by dx. One p I get if I integrate by dp by dy. If I multiply these two, then I have p. The net p is area. Now, if this is the area, then p vector, that is the curvature vector, is not the curve vector. Then this is the area vector. Now, area vector would move on the full sphere in a three dimension, not in a line way or in a surface way. So dp by dx and dp by dy, if I multiply, and then means whatever dp by dp by dy, if I multiply and place the limit along x-axis and y-axis, we get the surface. This explanation is not anywhere. Okay, and this is a true explanation. Now that two vector, how we can multiply? Not possible. P is a dp by dx is a vector. dp by dy is a vector that we cannot multiply. There are two ways to multiply a vector, two vectors, that is dot product and cross product. Cross product talks about the calculation of the area. So if I do dp by dx cross product of dp by dy, then one length, other length of become two side, variation along x-axis and variation along y-axis. These are the two sides of the area that we are imagining. So if I do cross product, then we can think about the actual area of the A. So dp by dx cross product of dp by dy, and that cross product, if I integrate with dx and dy, what you get in the book is that then it will become dp by dx into dx. So this is the kind of something and this is something, and you multiply, you get this dx and dy. Dx and dy are symbol of calculating the area. They are not the multiplier. Okay. So why I am saying that concentrate on the algebraic function. That is the big thing, not dx and dy. So dx and dy are mere symbols only as far as calculus. This is what Mr. Newton or Sir Newton he would have thought about. So dp by dx cross product of dp by dy, that is the main item. That is the meat. That is the flesh. So I mean meat of the flesh of the fruit, not that meat. Okay. Nowadays it is very crime that if you talk about non-vegetarian. So we don't talk about non-vegetarian. So flesh of a fruit. That is the scenario nowadays. That it's a crime that you talk about non-vegetarian. Even though people enjoy non-vegetarian, I personally believe I am not non-vegetarian, but still I believe that non-vegetarian is the most tasty food that someone can have. I used to be non-vegetarian. So I am by birth I am a non-vegetarian and I used to enjoy non-vegetarian a lot. So I know how nice it is that you have really cooked flesh. But anyway, now the scenario is in the world is like that eating non-vegetarian is a crime. That personally I never think so, because non-eating non-vegetarian is the most enjoyable thing that you can have in your life. Pertaining to, you are not advised not to eat because of some health reason. Otherwise, there is no substitute as far as you enjoy non-vegetarian. If you have food in non-vegetarian, then it is like that your life is on zenith. Okay, so amazing. Anyway, we can do. Sometimes we are kind of in compulsion where we have health issues and whatever. So anyway, so now we are talking about integration, the flesh of the integration. So flesh of the integration is the algebraic equation. Then dx and dy is just notation to say that we have to do the calculate the area of this algebraic equation along x-axis and along y-axis. So we will see later directional integration also. Directional derivative we have talked in depth. Directional derivative. Directional integration also we'll see. Now what is the flesh? What is the flesh? That is dz by dx cross dz by, I mean dp by dx cross dp by dy. So one is I plus fx. I would say fx, dfxy by dx. I can say fx. I plus fxk, and another is j plus fyk. If I do cross product, then it would result in minus fxi minus fyj minus fxi minus fxi, because if I do cross product of, I mean cross product of I, here I and k and there j and k. So I and j, if I cross, it becomes k. I and k, if I cross, then it becomes minus j. So minus fxj, and here it is, okay, and here if it is fxi and there it is j, then it becomes fxk, and here there it is j, then fxi. So minus fxj minus fxi plus k. Now if I want the amplitude, then it becomes fx square plus fy square plus 1, the square root dx and dy. Then you have to provide the integration. I believe a lot of times now it would not be a very difficult from kind of, if you think in a step by, we'll try to finish it, then we'll move to 3D, more example on it. So now we have come that if I find integration, as far as the 2 dx and dy is concerned, then function we are integrating is a square root of fx square plus fy square plus 1, and then integration based upon whatever the x and y in the sphere. So x is minus 1 to 1 and y is again minus 1 to 1. If I do, then I get the heavy sphere, the surface area of a sphere. Then I can multiply by 2 and I get the result. So probably we'll work out in this example and we will see.